I propose for a fuzzy bacteria for it. I introduce a fuzziness in the optation algorithm, where basically the C value which I have told one C value, if you correctly remember, this one. This value should be properly chosen so that your convergence will be faster. I have told what you are multiplying. So I simply give a rule that if your error is large, give the C small. If the error is small, make the C large. This was simply my rule. So with that, I formulated 4 rules. If the error is large, C I think was 1 or something. If the error is small, medium, then C is high. If the error is small, C is 30. Like that, I go on continuously increasing it. Right? So here I saw that my convergence become very, very fast. That is because when I am reaching towards the converged value, if I am increasing by a large amount, then I will get the convergence faster. It will not create much problem. But at the initial stage, when the error is high, if I am again putting a large value and I am disturbing the performance, then I may not able to get the convergence. So initially I put it small, let it converge fast. Once it converges, I track it and I increase the value suddenly. So with this simple logic, the convergence become very, very fast. Okay, and this has been proposed. And it is found that under no noise condition, this table is very important, particularly for this problem. You may get this type of table for different problems. See, DFT, which is discrete Fourier transform, or FFT, when there is no noise, the error is 10 to the power minus 29, means almost 0. So it is very accurately predicting my frequency and amplitude as well as phase angle. But GA as well as bacteria foraging are having certain values. Error is around 1% here and 0.3% here. So under no noise condition, you can conclude that it is inferior to DFT. But when I am getting a noise, putting a noise, because the issues which I discussed, it will introduce a new frequency. The error becomes 10% with 10 dB, whereas GA becomes 2% and FBF is 2%. Right? So GA and FBF, no doubt they are going in parallel, because both of them are parallel algorithm and both of them may reach to the final global point. But here the time of convergence is 0.3 seconds, whereas this is 0.6 seconds. So almost 50% reduction in time is achieved. Therefore, FBF may be a better choice for GA in this particular course. So many other cases has been tested and it is found for the same. Okay. In fact, this bacteria foraging also has been applied to many other problems, and couple of papers has come. I have applied this to, one is which I discussed, then I applied for controller optimization, then I have applied it for loss minimization of power system, then I have applied it for I think same controller for another system. So many papers are there. So in that case, this is another example of bacteria foraging. Here I am not going into detail because you may feel bored, because it is more on towards electrical. But the issue is here, you see. I am having two parameters, that is the PI controller. You don't go into the detail of PI controller, but there are two parameters which needs to be optimized, and I have to design the controller. So when I am designing the controller, my issue should be overshoot should not be very high, it should not cross or should not oscillate much, and settling time should be as quickly as possible. So with these two objectives, I will now optimize the KP and KI. You must have been exposed to multi-objective yesterday. So that thing can also be now used for this KP KI optimization. Okay. So here you see, this is the pattern, this is the bacteria foraging one, and this is the GA. Bacteria foraging is quite faster compared to that of GA. Even for this problem we found that. But if you clearly or that means in-depthly see this one, GA is having somewhat better result compared to bacteria foraging. Slightly bacteria foraging is above GA. So here bacteria foraging is not reaching to the global minima as that of GA. But this difference I don't mind, but I need a faster curve. Therefore this paper got accepted, otherwise this would have been rejected. Okay. So these are the response, and this has also been used for transmission loss. This is a system model, power system model, where there are many transformers, and those transformer tapping of the transformer are to be adjusted so that my voltage changes. As a result, I will get reduced transmission loss. So objective is transmission loss reduction, and what I should get, what should my tapping condition. So my bacteria foraging will tell me these are the taps, use it for the optimization. Okay. So these are the some of the comparison. CGA means conventional GA, which we generally consider. DGA is differential GA, and FBA is bacteria foraging algorithm. Okay. So this is all about my bacteria foraging discussion. If you are having any doubt, ask.
To 12, Vidyasagar will conduct that lab. So tomorrow is not a half 12 or 1 o'clock, 3 hours lab will be tomorrow.
Mussoorie again.
Two of you will be going. Not all. So let the lab continue. Sunday. Monday. But all day.
So we were discussing about the evolutionary computation, and that is in particular about the evolutionary computation, and that is bacteria foraging algorithm. The next topic of this lecture will be on fuzzy control. As I was just mentioning, fuzzy controller or fuzzy systems, when I will speak, it is taking care of uncertainty in the input and output area. However, when you see a controller, it must be crisp to crisp. Means whatever input you are sensing, whether it is voltage, current, power or anything, that is a numerical value. Output must be a numerical value. You cannot say your controller or firing circuit or anything, that it is a medium firing engine, it is a large firing engine, because it will not understand. You have to tell a crisp value for the output. So in case of fuzzy systems, input is crisp, output is crisp, but in between you are doing the operations, and those are some of the mathematical operations. So if you see here, this is your command variable, which is the controller, and this is the plant from which we measure certain variables, and that is fuzzified. Then it is going to the expert rule. This is your expert rule, fuzzy inference engine. Then it is again defuzzified and you get the numerical. So this portion is numerical domain and this portion is the linguistic domain. So you are sensing the voltage, current or any of this sort from the part, which is a numerical value. Similarly, the controller must be a numerical value, and this is your linguistic value. Okay. So with this basic concept, I will now go for my presentation. Now there is a problem. The problem is the container is carried by the crane, and this container is to be put over the trailer. Okay, and I want to design a controller for this. This is a basic simple example. So when I am telling it is to be put over this trailer, it is governed by one distance and one angle. If I will specify to this crane that you move, or the head is to be moved by this much distance at an angle this much, then accordingly I can now design my power. Okay. So here to do this exercise, I need what? I must sense the angle at which the container is with respect to the trailer, as well as I have to know what is the distance of the container. So I have to sense the angle and distance. These two things are to be sensed. So those are in numerical value. Once I sense this one, it is passed to the fuzzification, and in the fuzzification we do this large, small, medium, this business. Okay. So whatever angle and distance I am getting, that is passed to the fuzzy membership variable. Just like I was giving the example that if it is 6 feet, then we categorize them into tall category. However, when it is 5.8, we little bit reduce it. So like that, this angle is to be properly fuzzified. Means we have to identify a proper class for this angle and the distance. Once it is classified, then it will go to the rule, and then it will go to the defuzzification. Okay. So now I have formulated, this is for only for example, I have formulated the rule: if distance is medium and angle is positive small, then power is positive medium. What I am telling? Remember this rule: if distance is medium and angle is positive small, then power is medium. Means power input to the motor of the crane should be medium. Similarly, the other rule is, if distance is medium and angle is 0, then power is 0. Then power is 0. if distance is far, angle is 0, then power is positive medium. So like that I have formulated certain rule. This rule formation is called as if then rule. If this is, then this is. This is called if then rule, which is designed by Lapti-Jade. Okay, and this and you see here it is written capital. It is written in capital. It is not in small. So this is not the and which we generally speak about. It is a logical and. It is not a linguistic and. Right? And this and, capital N, is defined as Jade's and. Similarly, there is another concept called leucistic or. Means I can formulate a rule if A is positive or B is negative, then C is positive. I can formulate a rule like that, where my operation is OR operation, and here the operation is AND operation. And what is the significance of AND and OR operation, we will discuss later. Okay. So I have been able to design certain rules. And who can design a rule? If he is an expert in the field. If he is not an expert, he cannot design it. Okay. So now suppose I have been able to design the rule perfectly, then I will go for the implication, that is firing strength of the rule, that is called as firing strength of the rule. Okay. So when I was having the membership function, I am having certain membership function like this. This is my angle and this is my mu, membership function or membership value, and this is 1. This is my positive and this is my medium. Okay. Now if I am having a angle here, this is suppose let us assume 30 degree, some angle I am getting. So this 30 degree belongs to the medium category with this much value, okay, and this belongs to positive category with this much value. Okay, just like suppose you are having a 5.5 feet person, then you are hesitatingly categorizing him into tall category. So there is a chance that he may go to medium category or may go to tall category. So I will categorize him that there is a chance it is 50% to tall and 50% to medium. Okay. But if it is 5 feet, it is never tall. It is always medium. So that's the implication here. So when it is here, it belongs to medium category with suppose 0.2 and belongs to positive category with 0.8. Means its belongingness to the positive is more compared to that of medium.